Okay, so for this small video, hopefully it'll be a little smaller than the perfect squares trinomials, but anyway, the difference of squares is factorable. And if we build it, we kind of look like this. Ax minus b, ax plus b. If I go ahead and I multiply this through, and I'm going to write down all of the terms that expand, a squared x squared plus ab x minus abx, and then minus b squared. So one thing you'll notice right off the bat is that the b squared, unlike the one that was in the perfect square trinomial, is negative. Also, these two terms here will eliminate one another. So the real outcome looks like ax, or a squared x squared minus b squared. Okay, so we have two things that are perfect squares, and there's a difference between them, hence the difference of squares. If we can identify them as perfect squares and they are a difference, then we can split them up this way, which is the front of each factor is the root of the front, the back of each factor is the root of the back, and you just simply use opposite signs. All right, let's take a couple of these here. So we'll have something like 4x squared minus 9. So we take a look at this and we say, all right, well, 4 is a perfect square, 9 is a perfect square, and x squared is a perfect square. So we take our roots and we say, well, what did I multiply, or what did I square to get 4? 2x and 3. 2x and 3. And then you just put opposite signs. It doesn't matter which order you put them. So you notice up here I went minus plus, here I went plus minus. It doesn't matter. Either one, that's fine. So, but you notice it's just that that quick. I mean, if this can happen, perfect, awesome. If not, then you got to do something else. So the primary check for this is the difference of squares. There's only two terms. Are they perfect squares? Yes. Then there it is. That's it. If you can't remember to do this, then what you can do is you can put a zero term in there and factor just like normal. So 4x squared plus 0x minus 9, and then you can factor this out like you would any other trinomial. You will still come up with 2x plus 3 and 2x minus 3, the order of which will depend on how exactly you go about reordering these terms. Be cautious that this central term here carries with it the proper variables. So the power on the variable here is always half of that at the ends. So if I happen to have 4x squared and then a minus 9y to the fourth, let me just write that out. Let's say I had this. In that case, if I wanted to rewrite this as a 3 term and then go ahead and factor it just like normal, it'd be 4x squared plus 0xy squared. It's half of the exponent minus 9y to the fourth. If you don't put half of the exponent, when you get to the separation and then factoring by grouping, you're going to be off because nothing's going to work right. And it's not because you didn't necessarily group correctly, it's because your assumption on the central term was incorrect. So just be very cautious when you're rewriting these if you're not going to use the specials, as I refer to them. But that's it. That's the difference of squares. They all work like that. Now, there's a problem. And a lot of people tend to not remember this. But the sum of squares this is not factorable in real numbers. Now, if you are coming to this video and you're like, well, wait, I know what the imaginary number is. All right. In that case, you can follow along. If you've gotten to this point and you're just like, I have no idea what an imaginary number is, stop. You don't need to go any further. Just know that the sum of squares is not factorable in real numbers. That's it. So you're just done. You see a sum of squares, you're done. If you happen to have stuck around and you're like, well, wait a minute, why can't I factor this out? Well, we're trying to find something that will produce a positive at the end, but also cancels out or eliminates the central term when you expand it. So if we were to go back and take a look at our perfect square trinomials, that sort of thing, we would notice that we have a plus at the end, but the middle term always adds in order to generate. So the problem with it is there's always a central term, but we can't allow a central term here. As it turns out, there is a way to factor this out, but you have to use imaginary numbers, and more specifically, complex numbers. So this is going to be 2x, just like before, but this is going to be plus 3i, and then this is going to be 2x minus 3i. Now, if you're familiar with the imaginary number, that's perfectly fine, but I stands for the square root of -1, which means that I squared is equal to -1. So when I multiply this back out, I'm going to get 2x, or I should say 2 squared x squared, and then I'm going to get a plus 6ix minus 6ix, and then I'm going to get minus 9i squared. But this minus this I squared is equal to -1. -1 times -9 is positive 9. So this is actually 4x squared. These two are going to eliminate one another. And then you're going to get this -1 times -9 for positive 9. But you have to have the imaginary number I in order to do this. So if you stuck around and you're like, I just want to see how this goes, the sum of squares is not factorable in the real numbers. Don't do it. It's bad. If you try to do it, check your work, make sure that you've gotten it straight. You'll find out that in fact it will not multiply back out the way you want it to. So don't assume it will. The kiss of death for the vast majority of students here is when they see a perfect square, such as let's use actual numbers here, 3x minus 1, and they square it. The first thing that they want to do is, because of all of their exponent rules, they just want to distribute the square. It is not the same as 9x squared plus 1. That is not the way that works. Remember that if you really want to do this, that means that you take 3x minus 1 and you multiply it by 3x minus 1. Doing so is going to give you 9x squared, but then you're going to get a minus 6x and then a plus 1. This minus 6x is the thing that's missing. So that's why you don't want to go ahead and do that. I hope this helps. This is just another check during that specials. This is my third step when it comes to factoring.